Today's video will be 6.5 solving equations containing rational expressions. It's going to be very similar to the last lesson in the sense that we will have to still find a common denominator because we'll be dealing with fractions. So what we're going to do is we're going to look throughout the entire equation. We're going to look at the three denominators, and then we're going to choose whether or not, choose what the common denominator is. So if we look at this, we have 6, 2, and 3. That means the LCD would be 6. Since it's 6, you have to think about what you need to multiply throughout, or multiply each fraction by. The first one's already 6, so we don't need to multiply there. But the second one, I would multiply 3 over 3. And then finally, the last one, it would be 2 over 2. This then gives us 5x plus 6 plus 3 over 6 equals 2x over 6. Now, once you look at this, they all have the same denominator. And if you think about how we cancel out the denominator in a normal equation, we would multiply by the denominator, which would be 6. And so if we do that, we would distribute the 6 and think about what happens. All the 6's just cancel out, and we're left with 5x plus 3 equals 2x. From there, you just solve. You bring the 2x over, you get 2x plus 3 equals 0. Subtract the 3, you get 3x equals negative 3, and x equals negative 1. You can double check your answer by plugging it back in. There are different ways to approach these problems. You can always find just the common denominator for each side and simplify it that way, and then cross multiply or multiply by the denominator. But finding the LCD and crossing out the denominator is the approach that I'm going to take throughout. But remember, there are always different ways you can approach this. So if we look at number 2, we have 5 over x minus the quantity 3x plus 6 over 2x equals 7/3. So we're going to think about what our LCD is. We need a 2, a 3, and an x, so the LCD is going to be 6x. So think about how you need to multiply each fraction. I need to multiply the first one by 6 over 6. I need to multiply the second one by 3 over 3. And finally, the last one by 2x over 2x. That will create the denominators to be 6x. So we have 30 over 6x minus 3 times the quantity 3x plus 6. Notice that I have 3x plus 6 in parentheses because I am going to distribute because it's the quantity of. And then finally, it's going to equal 14x over 6x. Now, I'm going to basically multiply by 6x, and what this does is it cancels out the entire denominator. And we're left with 30 minus 3 times the quantity 3x plus 6 equals 14x. And then I solve like a normal equation. I'm going to distribute the 3, combine like terms, equals 23x divided by 23, and you get x equals 12/23. We're going to look at a few problems that have binomials or polynomials in the denominator. In example number 3, you'll notice that the denominators are x minus 3. Again, you're looking for the LCD, which they already have one. And so since we already have the LCD, which is x minus 3, that's exactly what we'll do. We'll multiply throughout the equation by x minus 3. So I'm going to distribute to that term and that term. And again, it's just going to cancel out the denominator. And what you're going to get is x plus 5 equals 2 times the quantity x plus 1. Go ahead and distribute that 2. And you'll get 5 equals 1x plus 2, x equals 3. Now, the one thing that you do have to be careful about when you're dealing with rational expressions or equations is you'll have to look for what's called an extraneous solution. If we look at the original problem, we do have fractions, and what's going to happen is if you go ahead and you plug that in and you try to test this out, you're going to get 3 plus 5 is 8 over 3 minus 3, which is 0, equals 2 times the quantity 3 plus 1, which is 8, over 0. You can't divide by 0, so this actually is not a solution. So there are no solutions to problem number 3. And again, this is called an extraneous solution. All right, problem number 4. We have 3 terms. 3x over the quantity 3x minus 1 plus 1 over x equals 1 over 3x minus 1. Again, what you want to do is compare the denominators and look for the LCD. And remember how we mentioned in class, you simply just can't minus 1 to this. That's not how it works. You need to be multiplying in order to create the same. So the LCD in this case is actually going to be the two terms separated, x and the quantity 3x minus 1. So in the first term, I'm going to multiply by x over x. In the second one, I'm going to multiply by 3x minus 1 over 3x minus 1. And finally, in the last one, I'll multiply by x over x. That's going to give us 3x squared. Now, there's no need to distribute. You can if you want. But eventually, we'll just be canceling it out, so there's really no need. And you could probably do that in this step right here, not even show that, because we do know that if we have the correct denominator, when we go to multiply it, it does cancel out. So again, we're multiplying the entire equation by this, and so this cancels all of that. And we're left with 3x squared plus 3x minus 1 equals x. Now, you may have noticed when you're working on this that you have an exponent right here. That makes it a quadratic. And if you remember how we deal with quadratics is that we try to factor them. So we're going to bring the x over, set it equal to 0. And you can either factor by grouping or you can guess and test. I'll do by grouping just so you guys remember. 3 times negative 1, that's negative 1. Pick the factor pair that matches the middle, and then rewrite it. And again, you don't have to do this method. You can certainly do guess and check. That one, guess and check, would probably be pretty straightforward in this. Take out the 3x here, get x plus 1. Take out a negative 1. You'll see how that matches up. So we take the 3x and the negative 1, and we'll get the x plus 1 together. And then we solve. X equals 1/3, and x equals negative 1. You'll plug both of those in. If I plug in 1/3 and if I plug in negative 1, and you see if they work. If you plug in 1/3, 3 times 1/3 is 1 minus 1. That creates the extraneous solution. So that doesn't work. So our only solution here would be negative 1. Finally, our last example, number 5. Pause the video, see if you can find the LCD, and solve the equation. If I take a look at this, we have an x minus 4 and an x plus 4. And you'll notice we'll have x squared minus 16. Now, those are 3 completely different denominators, but hopefully what you should notice is x squared minus 16 should seem familiar. It's because it's a dots problem. I'm going to factor it to be x plus 4, x minus 4, and now the 3 denominators don't seem quite as different. What our LCD will be in this case is x minus 4 and x plus 4. Now you can certainly say x squared minus 16, but I think it's a little bit more beneficial to separate it as factors. So we're going to multiply the first one by x plus 4, because that's what it's missing. The second one has both of them, so we don't need to. And then finally, we're going to multiply the last term over here by x minus 4. Go ahead and distribute. So we'll get 2x times quantity x plus 4 plus 10 minus 5x equals x times quantity x minus 4. And again, I'm just going to get rid of all of this down here because we know when we multiply across, that's what's going to happen. So when we distribute, we get 2x squared plus 8x plus 10 minus 5x equals x squared minus 4x. I'll bring the x squared over along with the 4x. And I'll combine those like terms. So we have 1x squared. This is 12 minus 5, which would be positive 5x plus 10. Quick correction, this should actually be a 7. 12 minus 5 is 7, not 5. So then we'll look and we can see if that can factor, which it does. So x plus 2, x plus 5. And our solutions are negative 2 and negative 5. And what you're going to want to do is just plug both of those back into the equation up on top to make sure that they work. Both work. So we have two solutions for this, negative 2 and negative 5.